In this video, we're going to look at how do we determine the distance and midpoint between 2 points on a graph. So we're given the points 1, 1 and 4, 5. And we want to know what is the distance and midpoint between these 2 points. So the distance is, what is this? And if you look at the formula, it looks quite complicated, but actually what it is a restating of the Pythagorean theorem. So we'll go ahead and look at this in a different way, more graphically or visually first, before we actually look at this formula. So what we could do is sort of drop down straight from this point until we reach this point here, and then draw over to the right until we reach our other point. And what you'll notice is we've drawn a right triangle. So this point was 4, 5, and this point was 1, 1. The first coordinate is the x-axis. So we started at 1, and we moved over to 2, we moved over to 3, and then we moved over to 4. So this side right here has a unit of 3, or a value of 3. We started at 1, so going over 2 is 1, going over to 3 is 2, going over to 4 is moving over 3 units. This side is going up and down, so this relates to the y values. We started at 1, and we're going to 5. So going up to 2, then 3, then 4, then 5. So we've moved up 4 units. And you can see what we have is a right triangle with 2 of the legs, and we don't know the hypotenuse. So the distance between 2 points, what you're really figuring out is what is the value of the hypotenuse. And we know the Pythagorean theorem is a squared plus b squared equals c squared, where these are our 2 legs and this is the hypotenuse. So we can do 3 squared plus 4 squared equals c squared. This is 9 plus 16 equals c squared, which is 25 equals c squared, or c equals 5. And c is our hypotenuse, and in this case I labeled my hypotenuse x, so x equals 5. And that's the distance between the 2 points. So what this formula is saying is this is basically the c value, the hypotenuse. And it's not squared because we took the square root of both sides, so that's why we have this sign right here. And then this right here, this is the a squared. And this right here is the b squared. And delta, that means change. When you're calculating change, you're subtracting 2 values, so that's why it's x2 minus x1. So 4 minus 1, and then y2 minus y1, 5 minus 1. So if we were to plug in to this equation, x2, doesn't really matter if this is x2 or if this is x2. I usually choose the further right one to be x2, but it doesn't matter. What matters is if this is x2, this is y2. So that's x1. Its ordered pair is y1. That's what's important, is that they have the same number. Okay, so x2 is 4, x1 is 1, that's squared. y2 is 5, y1 is 1, that's squared. If we simplify, that's 3 squared. This is 4 squared. That becomes 9 plus 16, which is 25, and the square root of 25 is 5. So you can see this formula, it's really just a rearrangement of the Pythagorean theorem. So if you didn't remember this formula, that's okay. You can figure it out just by doing this with the Pythagorean theorem. Alright, so that's distance. For midpoint, what we're looking at is we're essentially trying to figure out this point right here. And we can kind of eyeball it. So if I drew over here, it looks like it's around 3. And then if I drew down, it looks like it's around maybe 2.5. But we can do better than just eyeballing it, because with drawings you might be off just a little bit. What this formula is essentially telling us to do is take an average of your x coordinates and take an average of your y coordinates. Because if you're taking an average of two things, x1 and x2, you have to divide it by 2. And then same thing with the y coordinates. You're taking an average of two things. You add them together, divide by 2. So x1 plus x2, x1 is 1, x2 is 4, divide by 2. y1 is 1, y2 is 5, divide by 2. So we end up with 5 divided by 2, comma, 6 divided by 2. 5 divided by 2, you could leave it like that, or you could report it in decimal form as 2.5, and then 6 divided by 2 is 3. So actually that did come out fairly close to our prediction. We predicted 2.5 for the x, and then it looks like it's a little bit over 3 for the y value, but that's just because I didn't do my drawing perfectly. So actually the midpoint is 2.5 and then exactly on the number 3.